with the video lecture series of Department of Robotics and Automation on the course of Control System Engineering. So today we'll be discussing about the topic of block diagram reduction. So initially we'll be having an block diagrams. The control system will be represented in a pictorial representation in form of block diagram. So we need to find a transfer function for the particular system. So we need to do some block diagram reduction. So the system will be represented in forms of block diagram. So we need to reduce that block diagram to find the transfer function. So for reducing those block diagram, we have some rules to reduce those block diagram and find a transfer function for it. So we have the basic 9 rules to reduce the block diagram. So initially block diagram, which is nothing but, so we'll be having a control system. The whole control system is represented in the pictorial representation form of the system being done in a block diagram. So if you need to find the transfer function for the particular system, so what we need to do, we need to first reduce the block diagram. After reducing the block diagram, we'll get the final transfer function. The transfer function, which is nothing but Laplace transform of your output divided by Laplace transform of an input. So the first rule of your block diagram reduction is, if you have the two blocks, the block G1 and block G2. So we have the two blocks. So we are giving some gain signal. The gain signal, which is an X. So if we have the block value G1 and G2, so we can reduce this block by, how we can reduce this block? We can reduce this block. So here the blocks are the first rule. If the blocks are in series or are in cascade. Series or cascade. So now the block G1 and G2 are in cascade. So if the blocks are in series, we can combine this block as a single block. Combine this block as a single block, which is G1 into G2. So we can multiply the values of both the blocks G1 and G2. So the input signal value is which is nothing but X. So here the output of this block G1, here the output of the block G1, which is nothing but the signal value into this block value. So it is nothing but X into G1. So it comes back to here the output of this G2, which is nothing but signal value into this block value. Signal value, which is X into G1 into this G2. Right. So the output of this two blocks, which is nothing but X into G1, G2. Right. So now comes back to here. So the same value will get us an output here. So the input signal, which is X, the value of the block is G1 and G2. Reduced block is G1 and G2. So we have, so whatever it may be, so we have reduced the block diagram also. We have reduced this blocks, two blocks. We have combined these two blocks as a single block by using the rule 1, which is in both the blocks are in series or cascade. We can reduce it as a single block by multiplying the values of both the blocks. So if you are having an n number of blocks like G1, G2, G3, so we can multiply it as in G1, G2, G3 till G9. So this is your first rule. So the first rule, which is nothing but, so the first rule, so when your blocks are in series or cascade, we can reduce the block by multiplying the values of the block. So if you are having a G1, G2, for example, here I have taken a G1 and G2. So it might be in your problem, it might be an H1 and H2 or some values like A, B, some other thing like that. So your second rule is like, so if your blocks are in parallel. So the blocks are in parallel. For example, you can take G1 and you can take another block, it is G2. So you have some summing point. So this is signal. So you have the signal, the input signal might be in your X. So you have the block value G1 and G2. So both are in the direction of in forward. So both the blocks are in forward direction. So G1 and G2 both are in forward direction. So here it's plus and plus, the summing point. So you need it is like your both the blocks in forward direction, it's meeting it at some summing point. So this point is called as a summing point. So what might be your output? So your output will be, so if both the blocks are in parallel, you can add up the values of both the blocks. So how you can add up? So G1 and G2 are the values of the block, right? So you can add up like G1 plus G2. So you can reduce this block as a single block by adding the value of the block G1 and G2. So your input signal, which is nothing but your X, and the value of your block is G1 plus G2. Reduced block is G1 plus G2, and your output will be how the value, the signal into the value of the block G1 plus G2, right? G1 plus G2. So when you are taking here, so what will be an output of this block? So you have a signal X and you have the block value G1. So the output will be X into G1, right? So what will be the output of this block? The signal you have here X and you have the block G2. So which is nothing but X into G2. So both the signal which is leading into one summing point. So what happens? Both the signals get added together, right? So when you are adding together, you will have X into G1 plus X into G2. So you can take X outside, so you will get G1 plus G2. So right, so this is the value you are getting. So your when both the blocks are in parallel, the output is nothing but your X into G1 plus G2, right? The same value when you reduce this block as a single block, you get the same value X into G1 plus G2, right? So this is the main basic two rules which is there. The one is both the blocks are in series. You can combine the block into one single block by multiplying the values of the blocks, right? If the blocks are in parallel, what you can do? You can combine into one single block by adding the values of the block, right? So here G1 and G2, so I am adding the block and I get G1 plus G2, right? So your next rule is you have something like moving and takeoff point ahead the block. So ahead the block, so something is takeoff point which is nothing but, so if you have some values here, so this is some branch point or something. So this might be your takeoff point or branch point. So when we need to move this takeoff point ahead the block. So after the block I need this one. So what the rule I can apply here? So the first thing, so you have the block that is in block G1, right? And you have some takeoff point here. So this value is X. So now what I need is like I need to move this. This is the takeoff point. I need to move this takeoff point to ahead the block. So when I need to move a takeoff point to an ahead the block, what I need to do, the first thing is which path I am moving. So I am moving this branch point, right? So I am moving this branch point. So to that branch point, I need to add a block. So the value of the block will be a reciprocal of the value which I have it as a already have to which block I am moving that block value. So for example, so now I am having the block G1. So I am moving this branch point, this takeoff point ahead this block G1. So how I get an so this is in G1. So I have moved this block this branch point here. So I have moved this branch point. So I need to add a block. Right? So it is G1. So the reciprocal of that value. So 1 by G1. So again 1 by G1 as in value. So this is how you'll have. So you have the output will be here. You have the X and here X into G1. X into G1 and the same thing will get an same output here. So this will have an X. So X into G1. And here 1 by G1 will have get cancelled and you will have your X as an output there. So this is your moving a takeoff point ahead the block. So the next rule is like moving a takeoff point before the block. So before the block in the sense. So now if you have the G1. So if your takeoff point is here, I need to move this takeoff point to before the block. So what the rule I can apply? So for example, you can take the block G1, right? So I have some takeoff point is here. So some takeoff point is here. So you have the value of X. So now I need to move this takeoff point to here. The rule is like, so whenever you are moving the takeoff point or branch point to some other block, so the moving you need to add the block in a moving branch. So I am moving this branch, so I can need to add the block to this branch. So I get like, So okay, we have so G1. So I'm moving this branch point, right? So I have moved this branch point. So what I need to add? I need to add a block value which is the same of that value. So in which block I am moving? So I am moving the branch point before the G1, right? So the same value G1 I need to add in a block. So right. So this is how it gets. So you need to add the. So I have moved this branch point. So this is the branch point here. So I have moved the branch point to the block before the G1. So in branch I have added the block which is G1. Right. So your next is like interchanging in summing point. So interchanging summing points. Interchanging the summing points. So interchanging the summing points, right? So you have, for example, you have the two summing points. So you have the two summing points here. So this is your signal A and this is your signal B. So it is in summed up. So the output of this will be your A plus B, right? So when you comes here, so here you have the another signal C. So here plus and here it is plus. What you have again, you have this an A plus B sum up with the signal C. So when I need to interchange this summing point to the here and this summing point to here, that is also possible. So you can change the summing point. So you can interchange the summing point as such. So here might be your C, and here you can add signal A plus B, or you can so here you can add as an A plus B. So here you get as an output as A plus B plus C. Right. So here you have the A and B. Right. So you can interchange the summing point. So far we have seen that 5 basic rules to reduce the block diagram. In next series we can discuss about the remaining rules to reduce the block diagram.